Hello and welcome to another LeetCode video. Today we're going to be doing the problem of the day for June 25th, count all possible routes. And so I'm going to explain this problem. So you're given an array of locations and you're given a start and a finish and a fuel. And the distance between two numbers in the array of locations is the absolute value of difference of the two values. And so we want to show every single possible route that uses up to the fuel that we have that starts at index whatever we're given and ends at index whatever we're given. So for example, for this first one, our locations is 2, 3, 6, 8, 4, and we are starting here and we are ending here. And we have 5 units of fuel. So this one is pretty easy to see if we actually draw these on a number line. So we have something at index 2, something at index 3, something at index 4, something at index 6, and something at index 8. So we are starting here, and we're trying to get to here, and we have exactly 5 units of fuel. So it's pretty easy to tell that anything that's on the way is going to be fine in the path, right? So we can go straight 3 to 8, or we could stop any one of these. So like any one of these should be valid, if that makes sense, because we have exactly 5 units of fuel. So we can go here. This would be one path, right, where we go visit every single thing. Then we can go something like go here and then skip this one, or we can go like this and so on. But everything, as long as our path includes anything on this 3, 4, 6, 8, we're totally fine. And so this 3, 4, 6, 8 are indices 1, 2, 3, 4. So you can go 1, 3, 1, 2, 3, 1, 4, 3, 1, 4, 2, 3, and all of those are fine. Okay, now let's go to the second example. So we have our locations is 4, 3, 1. Our start is index 1. So start. Finish is 0. And we have 6 fuel. So let's say FU 6. Okay, so we have 6 fuel. So that means, well, where can we go? So we have to start at this 3 and we have to end at this 4, right? So this is the start, this is the end. Okay, so obviously 3 to 4 is a valid way to go. Right, so they're showing that. Okay. Now, what's another fair way to go? So we can actually go 3 to 1 to 4. And that would be totally fine as well, because we're using 2 fuel here and then 3 fuel here. So it's totally fine. We end at 4. Here we're only using 1 unit of fuel. And then another one is 1, 2, 1, 0, which would be 3, 1, 3, 4. And so as you can see, you can repeat things and you can go to the same place multiple times. So this would end up using 2 units of fuel, 3 units, 4 units of fuel, and then so on. So you can just keep trying like all possible combinations that start here. And so what would be like the recursive case here if we think about it? So let's actually think about the recursive case for this problem here, right? And then let's actually draw like a decision tree for this. So we have to start at 3. So we're going to start at 3. And this is going to be, let's just say we're starting at index 1. Okay. Now let's just draw our decision tree for everything. So from index 1, we can go to whatever index we want. We just cannot go to the same index. We can go anywhere else as long as we have enough fuel. Okay. So from index 1, we can actually go to index 0 or index 2. And so let's do that. So let's go to index 0, let's go to index 2. And how much fuel are we taking up? So let's actually record that. Let's actually record a tuple of the index and how much fuel we have left. So we have 6 fuel here. Index 1, fuel 6. Okay, now we go to index 0, which is a 4. So that's 1 fuel. So we're going to have 5 fuel left. And if we go to index 2, which is a 1, so the difference between 3 and 1 is 2, so we're going to have 4 fuel left. Okay? Now from index 0, we can go to index 1 or index 2, right? We can keep looping. So if we go from index 0 to index 1, that takes 1 fuel. So we would be at 4 here. And at index 2, how much fuel is that? So at index 2, we would take, from index 0 to index 2, that's 3 fuel. So we would have 2 fuel left. Okay, now from index 2, once again, we can go either to index 0 or index 1. And so from index 2, if we go to index 0, that's 3 fuel, so we would have 1 fuel left. Okay, index 1 would take 2 fuel, so we'd have 2 fuel left. All right. And so you could see that this 0, 1, 0, 1, 0, 1, 0, 1 is going to go all the way down. So that would be one way to do it, right? So let's actually draw that whole branch out. So this is going to be 0, then we're going to go to a 1, then we're going to go to a 0, then we're going to go to a 1, and finally have no fuel. So 0 is going to have 3 fuel, 1 will have 2 fuel, 0, 1 fuel, 1, 0 fuel. And so this is like a base case where we ended up at a 0, but that's not where we want it to be. So let's figure out how we would, let's actually fill out the rest of this tree, and then we can see how we would actually calculate the paths. Okay. So let's do this one right here. So this 2, 2, where can we go? So from the 2, we can either go to a 0 or a 1, right? So from the 2, we actually can't go to a 0 because from the 2 to 0 takes 3 fuel and we don't have enough, so we can only go to the 1 in this branch. So we'd have to go to the 1, and now we have no fuel. Okay. Now we are at 0 and we have 1 fuel. Where can we go? We can only go one place. We can only go to 1, and we have 0 fuel. Now we're at a 1 and we have 2 fuel, and we can go to the 0 or the 2. So let's say we go to the 0, we would have 1 fuel. And then if we go to the 2, we would have 0 fuel. And that this 0, 1 can only go to 1, 0. Okay, so now pretty much what we need to ask. So what does this actually ask us, right? So this problem actually asked us, what paths can we have that end up at, let's see, the finish needs to be this 0 node, right? And so we can end at this 0 node, and we can end prematurely. So we can end at the 0 node with fuel left over and just choose not to go anywhere. So pretty much what this is really asking us is how many times did we go to the 0 node? So we can count this up, right? So we have 1, 2, 3, did I miss anything? 4, 5. Hopefully that is the number of paths. Yes, that's 5 paths. So all of these paths, yes, we did go past like where we needed to go, but we could have just stopped, right? As you can see in this example, like we can just go 1, 0, 1, 0, use 3 fuel, and then just stop. So we don't necessarily have to use all our fuel. We mainly just have to figure out like, okay, what's our decision tree going to look like, and then how many of the n node are on the decision tree, and that's our answer. Okay, and so let's actually try to build up. So as you can see, this is dynamic programming because you are going to have repeated states. And so let's actually figure out how we can do that, right? Like we have this 1, 0 here, we have this 1, 0 here, and so on. So let's actually figure out what would a recursive memoization solution look like here. Let's think about that. Okay, so what variables do we have? Well, we obviously want the fuel, right? So the fuel, and how expensive is that going to be? So as you can see, the fuel is between 1 and 200. So let's say fuel equals 200. That's the maximum states we can have. And then we also want the index, right? So we want the index. So how expensive is that? So locations length is actually only 100. So if we have I, it's only 100. Okay. But we also have to, so we have a fuel and an index. Index is going to be our current location. Fuel is going to be how much fuel we have left. But also in our recursive DP, we do have to, from the path we're on, we do have to try to go to every other path. So how expensive is that going to be? We're going to have a loop in our DP that's going to go from the current path to every other path. How expensive is that going to be? Well, that's just going to be locations length again. So this is our two states, the fuel and the I. But then we're also going to have a loop in here that's going to go I times as well. And so our total number of states would be I squared times fuel. Now, is that too big or is that good? So let's think about it. So this is 100 times 100, which is 10 to the 4th. Okay. Now this fuel is 200, which is 10 to the 2nd, right? So this whole thing is going to be roughly 10 to the 6th. And 10 to the 6th should pass. And you can't really make this any better because at every single location with every single fuel, you are going to have to try to go to every single other location. Like there's no way to do that, but we are going to memorize. So we are going to calculate this only one time. So for every single state, we are going to calculate one time, but you got to remember that we are going to have this loop. So it's going to be I squared fuel time complexity. Okay. And you can't really make it any more efficient, but that should be able to pass. So honestly, this question, it is a hard question, but I feel like the tallest billboard and the other question we had before that, like the arithmetic subsequences, were definitely much tougher. Because for this one, you can make a nice memoization solution that's pretty straightforward, not too tricky. Where for the other ones, the memoization solution was actually really tricky to find, and we had to do some tricky thing with the variables to make sure it could actually pass, right? Like for the tallest billboard, we actually had to use a difference instead of just take all the variables we have. Where here, we can literally just take every variable we have, throw it into a standard memoization solution, and it should be able to pass. So let's do that. Let's code that up. So we have the visited as always. Now we're going to have, okay, hold on, set this. So we're going to have the standard DP. So we're going to have an index, and we're going to have a fuel. And what's going to be our base cases? So our base case is actually going to be if we're going to try to visit cities prematurely, and sometimes we're going to try to visit something that the fuel is going to be negative in. And so if the fuel is negative, that means that state is going to be 0 because we should never have been allowed to visit that. So we're going to try to visit things, and our base case is going to be when our fuel is less than 0. So if fuel is less than 0, then we know the state doesn't exist, so we can return 0. Okay? Now remember, we are looking for how many times we actually encounter the finished state in our whole traversion. So we do have one more base case, which is if this is in our dictionary. So if index fuel is in visited, then we can return visited index fuel. Okay, so that's another base case. And now remember, if we're at the finishing, like if we're at this finish, then we're gonna have to add 1 to our result because we just visited this finish. So we're gonna have some kind of result variable, and then we're gonna say if index equals finish. This is how we're gonna count up the number of times we've actually visited the finish index. So if index equals finish, then result plus equals 1, which means we need to add 1 to the result because we just that is one answer right there. And then we're gonna need to add to that, right? So anytime we finish. But remember, when we did get to a finish state, we can end there, right? So like if this finished 0, we can end at the 0, but we can keep going. So this is going to be the one that we add, and then we can keep going and we need to try other ones. Okay, so let's do that. And yeah. So now what are we actually doing? So now we just have to loop through every single state that's in locations, and we have to try to visit them all, and then we'll just see do we have enough fuel. So for I in range length locations, then we can't visit the current index that we're at, so we can visit every other one. So if I does not equal index, then we can try to visit it. So res plus equals dp of, and that's what's going to be I is going to be the new index, and then the fuel is going to be the absolute value of, so it's actually going to be fuel minus, and so the cost is the absolute value of the values at the 2 different indices. So that's going to be absolute value of locations I minus locations index. Okay, that's going to be the new fuel. And so we're going to visit every single, this is going to be our inner loop. Now we just need to save that. So visited equals this. Okay, and so here, now what we need to do is we need to do one more thing. So does this tell you that if the number is too big, return at modulo 10 to the 9 plus 7? So we are going to save this as this. And we are going to store that. We're going to do this in visited just to make the number smaller. Then we are going to return this thing right here. Okay. Now what we need to do is we need to just call, so we need to return dp. What's our starting index? So our starting index is actually going to be the start, and our fuel is going to be fuel here. And we're going to do that. And that should be it for the code, I think. So let's see how that goes. Okay, cool. So we got a solution. Now let's think of the time and space. And like I said, I think this one's definitely easier than the previous ones because you can just fit everything into a nice recursive memoization, pretty straightforward, just cookie cutter memoization. Okay, so time. So what do we have? So we have this index, which is the length of location. So just say that's L. Now, in our actual DP, we do have this loop where we're trying to go to every single other location. So that's L squared. And we do also have this fuel, and fuel can be 200 or more. So let's just say this is fuel. And so that's our solution, L squared times F. Now let's think of the space. So the space is going to be the actual memoization array. And so that's going to be L times F fuel. Okay, so that's going to be it for this problem. Hopefully you liked it. And if you did, please like the video and subscribe to the channel. And thanks for watching. I will see you in the next one. Bye.